So welcome to the Unstructured Data Analysis in the ArcGIS Environment webinar. Today we're going to be focusing on LocateXT and natural language processing. My name is Julia Bell. I am a solution engineer out of the DC office. I work on the defense team, so primarily with the DoD contracts, and I have a lot of customers who are using unstructured data analysis to deal with their problems. So as Margie mentioned, there will be specific times for questions, so I'm going to start by showing you guys LocateXT, and I'll stop about halfway through to open the floor up for questions, and then I'll move on to natural language processing, and there will be another break for questions at the end. So let's get started first by defining what exactly is unstructured data, because while a lot of you guys have probably used it, you may not know what the definition is. But simply put, unstructured data is data without a recognizable or rigid structure. So this is going to be most commonly your Word documents, your emails, social media, PowerPoints, PDFs, that sort of thing. And we have some examples here on the right now. So news articles and tweets are pretty common forms of unstructured data as well. So this is important to us because while we have a lot of unstructured data, a lot of that data is actually spatial as well. So I'm going to give you guys just a couple seconds if you could read the news article headline as well as the tweet below it, and try and pick out all of the spatial data that is included in those words. I'll give you a couple seconds to do so. All right, so let's see how you guys did. So in the news headline, which is only about 10 words itself, already 3 of them relate to spatial entities or locations. So we're referencing Ireland, the UK, Great Britain through Brexit. And then in the tweet below, we are referencing Syria deeply within the Twitter. We're referencing Syria just within the Twitter handle. The body of the tweet is going to refer to the US, the UK, and France. We're going to reference Syria again in the hashtag, and then also reference Eastern Ghouta. So while unstructured data is a lot of our data, it also has a spatial format, which is why we want to be able to use it. So I think that this quote, which was from 2010, is really important, showing that every 2 days, we create as much information as we did up to 2003. Now, this quote was from a decade ago, so the amount of data that we're creating now is exponentially larger. So what exactly does this look like? Well, every minute we are seeing hundreds of thousands of tweets, millions of text messages, emails, hundreds of thousands of Facebook status, Office documents, and all of this data is essentially unstructured. So while this isn't necessarily a big data issue, it does lead to the questions of how much spatial information are we missing out on? And then since we don't want to be missing out on all this spatial information, how do we capture this information in an ArcGIS? How do we use it in our ArcGIS environment to extract that spatial data and make it useful to us? So there's a couple ways that we can do that we can integrate this unstructured data within our ArcGIS environment. The first way that I'm going to show is using native Esri capability. So this is going to be using our software and our software alone. So in order to determine if this is the right move for you, you have to ask a few questions. So the first question is going to be, what exactly are we looking for? And the native Esri capability is going to work best with coordinates, custom locations, or user-defined keywords. So when your spatial information is in this format, and that's what you're trying to extract, the native Esri capability is going to work really well. And in order to do that, we use a tool called LocateXT, and this is going to be available in ArcGIS Pro, ArcGIS Pro for Intelligence, and ArcGIS Enterprise as well. So whatever format you're accessing our desktop software from, you can use it to access LocateXT. And this is best going to be used with data that is at least somewhat understood. So while the data does not have necessarily a structure, we're going to benefit from using data that has identifiable or repeating patterns. So messages that are repeated in the same kind of format over and over again. And since this is in that Esri environment, it's within our desktop software, there's little to no programming experience required. So if you are familiar with GIS softwares and tools, then you should be able to pretty seamlessly transition to using LocateXT. So how exactly do we go about doing that? How do we use ArcGIS LocateXT to extract locations from unstructured data? Well, LocateXT is a big E extension for ArcGIS Desktop and Enterprise. So this means that there is an additional cost associated with it. So it's not going to come with your standard license, but it is available starting in ArcMap 9.1 and ArcGIS Pro 2.3 and on, with 100% of the feature functionality available starting in Pro 2.4. So if you have the most updated versions of our software, you're going to be able to do everything that you're seeing me do here today. And this works by using what's called regex, or pattern matching regular expression, to search for coordinates in a variety of different formats within your documents. You're also able to use custom location lists to match and extract things like place names, codes, and other terms that you might have in your document. So some examples can be seen on the right. The first example is going to be extracting coordinates from a document. So the highlighted coordinates are what would be extracted. So in the middle, we have MGRS coordinates being extracted. So these are the standard coordinates used in the military. So as I mentioned in the slides, you're able to extract a variety of different coordinates, and LocateXT is able to pull those out. You don't have to specify what the format is. It's smart enough to figure it out on its own. And you can also extract multiple different coordinate formats from the same document, so you don't have to pick and choose. Then the example of the boarding pass on the bottom is going to show how you can use a custom location list to pull specific location codes. So in this example, the user has created a custom location list for different airport codes, and now LocateXT is using that to scan through the documents and try and find those 3-letter airport codes. And when it finds one of those, it's going to be able to plot it on the map with the corresponding coordinates as the user is given it. So LocateXT is accessed in ArcGIS Pro a little bit differently than a normal geoprocessing tool. So it's actually accessed through the Add Data dropdown. So instead of clicking Add Data at the top like you might normally do, at the bottom, there's going to be an Extract Locations tab, which will open up this Extract Locations pane. So this interface will allow users to drag and drop files or entire folders, as well as text, into the Extract Locations pane. So the text is really useful if you're just pulling information from a web page. You don't necessarily have the information in a document, but you want to really quickly put some points on a map. That's what you'd use the text for. And you are able to run this tool to create a new feature class or append it to an existing one. So we have a lot of users who are pulling messaging documents on a daily basis, and so they're able to, append each day that new document to the existing feature class instead of creating a new one. So it's also available within ArcGIS Pro for Intelligence. So if that's a software that you're using, you access it a little bit differently through the Data tab, but all the functionality is still going to be there. Now, while the most common way to use it would be with that Extract Locations pane, it is available as geoprocessing tools. So these would be in your conversion tools under your toolboxes. And we have 2 tools. This is going to be Extract Locations from Documents and Extract Locations from Text. So these are going to be really useful if you want to use LocateXT within a model, or you want to use it within a script in ArcPy. You can call these geoprocessing tools that way, the same way you would any other tool. All right, now I mentioned that LocateXT works best with data with somewhat of a pattern or data that's somewhat understood, and this comes into play when using the extracting custom attributes functionality of LocateXT. So this allows you to not only put points on a map, but create custom attributes within your feature class based on the information in your document. So you can do this by flagging specific keywords near a coordinate, or you can also do this by capturing entire strings and of text as well. So here's an example of how you would pull keywords from data. So in the example here, I am looking through some marine information. So this is a document containing different maritime observations. So what I'm doing here in the Edit Custom Attribute pane is I'm going to create a new field in my output feature class called Obstruction. And what I'm going to tell LocateXT is when it gets to a location, so when it finds a coordinate within my document, I want it to look 20 characters upstream and look for these keywords. And if it finds one of those keywords, I want it to pull that keyword out and put it in my new field called obstruction. So that would look a little something like this in the output. So in this first pop-up up here, we see where the coordinate was flagged here, but we don't see any of those keywords 20 characters before it. So our abstraction field is null. But these two examples here at the bottom, we notice that we have both rock and seamount, two of these keywords that I have in my keyword list. So it was able to not only flag the coordinate, but when it found that coordinate, it was also able to find the keyword and then put those in this new obstruction field that I've created with my custom attribute tool. So now that this is a feature class, I'm also able to symbolize it differently. So I can symbolize any of the outputs that had an obstruction associated with it in red and all those that didn't in green. So now I can begin to pull some structure back into my data. So not only do I have points on the map from the documents, but I begin to have a little bit of data associated with them coming through. So we can go a little bit further into this as well by not just pulling keywords that we know, but pulling keywords based on locations. So this example is a little bit more complex, but what we're doing here is I'm creating a new field called aggressor. I'm going to search near locations, and I'm going to search 50 characters downstream of wherever my location triggers. And I'm going to look for this keyword aggressor colon. So here I'm capturing the yellow is the coordinate. I'm going to look for that keyword aggressor colon. And when I find that keyword, I'm going to capture everything from the end of that keyword all the way until my stop string, which in this case is victim colon. So what I'm doing is flagging at the yellow, starting my capture at the end of the green. That's going to capture everything in blue. Then I'm going to stop at victim. So if you notice in this document, all of these messages are going to follow the same format as they come in. So that's why I'm able to build a custom attribute like this and take advantage of the structure that I know, or I'm sorry, the format that I know this data has. And I can go even farther. Instead of just capturing keywords, I could capture entire paragraphs here. So in this situation, it's going to look a lot like the example above, but here I'm creating a field called description. I'm going to flag based on my coordinate keyword, and then I'm going to look 180 characters downstream this time and start capturing at description colon and capture everything until date of occurrence, which is my stop string. So here I'm able to capture everything in the blue based on my start and stop keywords. I'm also able to tell LocateXT what kind of coordinate formats I want to look for. So in this case, since I've looked at my data, I realized that the coordinates are actually repeated here. And since I don't want to have duplicates, I don't want to have my coordinates flagged twice, I'm actually able to tell it to only collect degrees, minutes, seconds instead of degrees, minutes, coordinates to avoid some duplicate data. But after I run this custom attribute file, this is what my output would look like. Instead of just points on the map, I now have an attribute table which has this aggressor and description attribute fields as well. And now I can configure my pop-ups to include that description as well as to highlight what kind of aggressor type it was. So this is where LocateXT's power really comes into play, because instead of just putting points on a map, we're able to kind of grab some structure back into our data and get an entire description about what's going on. So now I'm going to show you how exactly this would look with a quick demo. All right, so this is ArcGIS Pro, which is our desktop software, and I can use it to access my extract locations pane here from the Add Data tab. This is going to cause my extract locations pane to open up on the right, and it's going to allow me to drag and drop specific data into my pane. So in this case, I'm going to drag this entire folder called source data into LocateXT. Then all I have to do is give it a name, and I can start to extract my information. Now there's a lot of data in here, so while we're waiting for that to run, I'm going to show you exactly what kind of things we're scanning. So here's an example of a PDF that's over 180 pages. So this is going to have a ton of coordinates in it. LocateXT is going to be able to scan all of that. I can also have these significant activity reports. So these are repetitive messages that are coming in as things occur. And as you can see, there's a ton of them. I can also bring in geotagged photos. So whenever photos are taken, they have coordinates inherently within their item details. So I can pull that as well. Sorry. And then I can also pull in PowerPoint information as well. So I'm using a ton of different data here, a ton of different formats and a ton of different data. And pretty quickly, LocateXT is able to grab every coordinate that's within that file and pull it down on the map for me. And now if I click one of these coordinates, I can see the extracted coordinate format, so it tells me exactly what the format is, as well as some pre and post text that can try and help give me a little bit of context into what's going on and where this coordinate was pulled from, as well as the file name. So this is really important in a situation like we have here, where I'm pulling an entire folder of data in to the software, because I may want to know exactly which document I was using and which document pulled that coordinate. So here I can see the pile path, and I can see exactly which of those documents within that source data folder it is pulling from. All right, so that was just the out-of-the-box functionality of LocateXT without any customizations. But what we can do here is begin to pull in something like a custom attribute file. So for this example, I'm going to use this ASAM data. So this is anti-shipping activity messages. So this is going to be like the example that we saw in the slide. It's going to be very repetitive messages coming in as different events occur. So you can see that we're going to have that aggressor field, as well as the victim field and the description, date of occurrence as well. So we have a lot of information here, and if an analyst were to have to go through and do this themselves, it would take a really long time. But with LocateXT, I can just pull that text file in. I can give it an appropriate name. And then what I can do is turn on my custom attributes feature to let it know that I am using a custom attributes file, which I've preloaded. But essentially, this custom attribute file is going to be exactly what we saw in the slides. So we're going to be able to use it to capture the date, the reference, the subregion, and then the aggressor description and victim like we saw here. And if we click into one of these, we can drill down a little bit more to see exactly what was added. We can see what our keywords were. We can see what our stop strings were. We can make this case sensitive. We can choose to include it in the capture or in our new attribute, what have you. So it's very customizable, and the interface is very simple to use. So after we've done that, we can go back to extract, and we can run this. And now LocateXT is not just going to look for those coordinates, but it's going to be looking for all of those keywords and the associated data with it. And if we look at all of the locations that are flagged, we can try to pull, a specific point. We can see that the coordinate has once again been pulled with the same extraction type, as well as pre and post text to give us some context. And then we can see at the bottom now that we have all this additional information based on our custom attributes. So we were able to pull the date, the reference, the aggressor, and description. So we were able to actually add a lot of information to our data. So instead of just having points on a map now, we have real information here that we could begin to symbolize our points on. We could customize our pop-ups like we saw on the slides. And with that, LocateXT is going to give us the ability to bring some structure back to our unstructured data. All right. So at this point, I am going to pause. We're about halfway through, and take some questions that you have on LocateXT.
Great. We have a few queued up here.
All right, perfect.
One person was asking if you can store the entire document in the geodatabase.
So the document cannot be stored in the entire geodatabase, but there is a way to configure your pop-up so that you can link it to where it would be on your machine. So while I had it just as kind of a string, you can configure your pop-up kind of as a hyperlink, and it would be able to let you click on it and pull you to that document.
Great. The next one, how many different coordinate formats and types does LocateXT recognize? And can you customize formats to expand location recognition?
That is a good question. Why don't we go down to LocateXT and we can look at that. So what we can do here in our options is we can click into this coordinates option, and this is going to be all of the formats that we have available. So decimal degrees, degrees, minutes, seconds, UTM, and then MGRS format. So these can be turned on and turned off. So for one of the examples, that PDF that I showed you had a huge table with decimals and numerical decimals. So I turned off the decimal degrees because I was seeing that when I had that on, it was flagging false locations. And then we can go ahead and customize that as well. So we can customize different coordinates based on different languages, that sort of thing as well. There's a lot of customizations that you can do here with those coordinates. So hopefully that answers your question.
Yeah, kind of a related question. Can LocateXT be used in place of convert coordinate notation for structured data?
So converting coordinates, not sure I completely understand the question, but it can't convert the coordinates that I know of, but we do have tools, obviously, that would do that. I think it would just really pull out the coordinates based on the format that it recognizes, and then you would probably have to go further to convert those coordinates if that's something you wanted to do.
Great, and I think the last question for now is, with a Word document, is LocateXT also looking at text or data in the header or footer, and would it do the same with the PDF?
Yep, so LocateXT is pulling everything from the entire document, whether that be a Word document or a PDF. So it's going to look everywhere. You don't have to specify, the body of the document. This comes into play a lot, actually, when we're using custom place names. So a lot of city names are the same for like people names. So like if there was something happening, if someone's name was Chad, and you had a custom location file with that country, it could flag that as a location. So that happens a lot. So essentially, yeah, LocateXT doesn't use headers or anything. It'll look at everything within the Word document, within the PDF, which can sometimes cause a little bit of an issue, actually. But so I hope that answers that.
All right, I think we've had some more questions come in, but I think we'll save those for the wrap-up session.
Okay, perfect. All right, so now we are going to transition into the second way that we can integrate unstructured data into our ArcGIS environment, and that is through third-party integration or using a different company's software here. So in this situation, we're going to be looking for what are called entities, and these are going to be locations, people, organizations, events, relationships, dates. So these can be spatial entities as well as non-spatial entities. And the best tool for this scenario is going to be natural language processing, which is used best on data that's not well understood. So this is going to be like your news articles, your tweets, that sort of thing, that aren't going to have that same pattern as some of the data that we saw used with LocateXT. And it does require integration. So the integration can be a little bit tricky. This is definitely going to be more difficult than using a native Esri capability. but it really does do a lot of different things. So it kind of depends on what you're trying to do to determine which one is best for you. So how do we go about integrating natural language processing with ArcGIS? So I have another example for you guys. I'll give you about a minute to go ahead and read this. And while you're reading it, I want you to try and pull out not just spatial entities or locations, but also those all different entities that we showed as well. So people, dates, times, that sort of thing. So I'll give you about a minute to run through this text document. All right, so let's see what you guys picked out because there's a lot of different entities here. So in terms of spatial entities, we're able to pull out a lot of information. So unlike LocateXT, we don't just pull out coordinates or place names. We can pull out entire countries. We can pull addresses. We can also pull coordinates, and then cities and things like this, approximately 5 miles northwest of Bakuba. So while this isn't a standard location, natural language processing is able to take that in and understand what it means enough to put a point on the map that would end up being about 5 miles northwest of Bakuba. So there's a lot of different spatial entities within this, but there's a lot of non-spatial entities as well that we can pull out and utilize with natural language processing. So here we can pull out Osama bin Laden, we can pull out the US Embassy, the Special Forces, as well as specific dates like 9/11, and specific objects as well, like 66 cruise missiles. And what natural language processing can do is connect these entities, be them spatial or non-spatial, to each other. So we're able to form linkages. So using natural language processing, we can link Osama bin Laden to Saudi Arabia because he was born there. We can link the US Embassy that's being mentioned in this text document to Kenya because that's where it's located here. And we can also link different events. So we can link Osama bin Laden to the attacks on the World Trade Center. We can link AMZ to the day that he was killed in 2006. So natural language processing is going to be able to go through. It's going to pull out all of these entities and all of these linkages and then store them within the data. So once we do that, how do we integrate these capabilities with ArcGIS? Well, first thing I'm going to do is tell you a little bit about some of these examples. So these are some of the natural language processing softwares that we've been able to integrate with. So this example here is NetOwl, we have Natural Language Toolkit, Microsoft Cognitive Services, TextBlob, and PyTorch. And these are just a couple of examples of NLP tools that we're able to use because a lot of them have Python APIs and SDKs that we're able to use to integrate pretty seamlessly with ArcGIS, with ArcPy. So this is important because it allows us to create these Python scripts and toolboxes that allows us to bring the software into our ArcGIS environment and bring that data onto our machine. So we also are able to use ArcGIS.learn, which is a Python library that we can use for entity recognition. So using these together, we're able to take these natural language processing softwares, and with their integration through Python, we're able to create things like this tool here that would allow us to then bring that information with the different entities and their linkages together and pull that into our ArcGIS environment. So how exactly would we go about doing that? So for this example, I'm going to show you my colleague and I used natural language processing in ArcGIS to monitor different news sources and pull down the data through their RSS feeds. So using Microsoft Flow, we were able to monitor when a new RSS item or article was published. And when that happened, we were able to pull it down via an Azure Logic app, an Azure Logic function, and run it through NetOwl, which is a natural language processing software that specializes in determining those linkages of different entities. So from there, we were also able to run it through Microsoft Cognitive Services, which is used for determining sentiment of different news articles, so determining if an article was positive or negative, that sort of thing. So we were able to run it through both of those, and then we were able to post that to GeoEvent. And from that, we were able to pull it using GeoEvent Server and bring it into our ArcGIS Enterprise and use it in our software. So this allows us to use it in the desktop environment, to use it in apps within the web, as well as we can pull it down to mobile as well. So once we've pulled it down through GeoEvent Server, we can use it as we could any other featured service in our environment. So the key takeaways of this is that this is leveraging modern serverless processes to integrate the apps. It really is much simpler than it used to be based on things like Microsoft Flow and the Azure Logic apps. And it also allows for a variety of different NLP processes to be ran. So as you noticed here, we not only ran it through NetOwl, but we were also able to run it through Microsoft Cognitive Services as well. So we were able to get a couple different things going here. And while the integration can be a little bit heavy, it can be a little bit tricky, there was actually little to no coding required because of Microsoft Flow and the Azure Logic apps. They really allow for a more UI-based format, so there's not as much coding required if it's something you want to take a stab at. So now let's go back into ArcGIS Pro, and I can show you exactly how we would use that data that's now been integrated into our ArcGIS environment. All right, so here we are now using ArcGIS Pro. So as I mentioned, these are going to represent different news articles. And these days we get a lot of our information from the news. But the problem with news articles is that by their very nature, they are an unstructured data problem. They don't have a specific format that we can use with something like LocateXT. So how can we use news articles to shape our perceptions, and how can we determine, what is a trustworthy news source? Are there different areas around the world that are real hotspots for news that I should be focusing on? And we can do that by using natural language processing in ArcGIS to start to answer those questions. So what we can do here, and what's being shown on the map, is the ability to analyze sentiment of these articles to look at areas that are experiencing really low or really high sentiment. So really good or really bad things happen to them. And we can also analyze the subjectivity of the article to determine how biased these articles are. So you can really know if the news that you're getting is accurate or not. And then we can calculate the polarity of the article to determine how extreme the tone is and how it might be received by different readers. So other techniques we're using, which is called entity extraction, are then going to be able to pull locations, people, organizations, relationships, and then events from the body of the article, which allows us not only to have the sentiment of these specific articles, but to plot them on a map and see the spatial relationships as well. So right now we have on the map the results of 1 week's worth of news that was pulled down in November. So what we're seeing here are all of the locations that were referenced inside these articles. And this data is captured from about 15 different global news agencies. So the locations can be styled then. We can show positive articles on the map only, or negative articles, or we can show them all at once if we want to get a better idea of what's going on. And using the charting capability of ArcGIS Pro, we can begin to drill down into our data and find a little bit more information about them. So we can see what are the news sources that we're getting these articles from. We can see that we're pulling the majority of these articles from Reuters, but we're also pulling from other notable news outlets like The Guardian and Al Jazeera. So this allows us to kind of process where we're getting our information and how many articles we're actually looking at here. So we can also create histograms for that different sentiment information. So the sentiment of an article, which is how the data is being displayed right now, is measured on a scale of 0 to 1, with 0.5 indicating a relatively neutral article. So the histogram we have here shows a relatively normal distribution with a slight skew towards neutral. So this is pretty good. We would hopefully, with all of the news out here, we would hope that, the good would kind of equalize the bad, which we're seeing here by the sentiment being pretty much neutral. We can also do this with subjectivity, which is also measured on a scale of 0 to 1, with 0 indicating an article with no bias and 1 indicating significant bias. So the distribution here is pretty normal. There is a slight skew indicating a relative amount of bias since it's around 0.37, but that's to be expected because even the best writers are going to have some of their bias come out in their writing. So we can also measure based on polarity, how well are these articles being received. So polarity is a little bit different because it is measured on a scale of -1 to 1, with -1 indicating an extremely negative view of the topic and 1 indicating an extremely positive view of the topic. So yet again, we're seeing a fairly normal distribution with pretty neutral numbers. The average is 0.06 here, which is pretty close to 0. So luckily, the polarity of these articles is pretty average as well. So now, since we have this information on a map, we can also examine some of the spatial relationships that are here. So using density-based clustering, which is a tool inside of the spatial statistics toolbox, we can analyze where clusters of news are on the map and if these news clusters are significant. So for this instance, I'm going to be using a method called HDB scan, which means that essentially the algorithm that we're using will use a self-adjusting radius until it meets the specified number of features for a cluster. So in this case, I want the number of features to count as a cluster to be 30. So it's going to keep expanding its radius until it finds 30 articles to determine a cluster. Now, I'm not going to run this here because it would take a pretty long time, but I do already have the data here on the map. So as you can see, we have numerous clusters on the map, and then there's some examples with a lot of clusters that we can drill down and examine further. So I mentioned this data is from November. So this is right around when the Canadian election was going on. So we can click on these points and begin to see what was being discussed at this time. So one thing that we were able to do here is actually create a word cloud from the articles that we pulled. So you can tell right away that they're discussing the election here, the campaign, and the multiple different political parties. We can also see the sentiment that's being discussed here as well. So right away, just by reading the title, we will be stuck with one of them. You can tell as humans that, this is probably not a very positive article. It's probably pretty negative. And if we look, the natural language processing software was able to pick that up as well with a sentiment score around 0.2. So relatively negative. So we can also look in different locations here, like South America. So if we go to Venezuela, during this time there was a pretty significant water system collapse in Venezuela, which we can tell is being discussed here in a lot of the articles within this cluster. So we can see in this case that some of the articles are detailing relatively negative views of the country's water system. Once again, the sentiment was reported as negative. The sentiment score is around 0.26. Which is relatively negative. So this combination of using not just natural language processing and sentiment analysis, but combining it with ArcGIS allows users to really be able to understand the news, not just in how it's being discussed, but also where it's being discussed and what information is most important. So it allows us to discover and investigate relationships, and through our spatial view, we're able to see what others can't. So the last thing that I'm going to show here is an example of this data being brought into a dashboard. So what we saw in the desktop software was kind of a static feature layer that had been pulled in November. But this information is coming directly from GeoEvent. We're still running that same process that's pulling down all the news articles, which is going to allow us to see that are happening right now. So it's going to show us of the articles, but also the different headlines. You can tell that this was pulled today, 4/28, at 12:37, so probably the last time I refreshed this web browser, we could go ahead and filter that out by article source if that's what we're interested in, and we can also filter the data based on when it was coming in. So the last week or the last 24 hours, what have you, what time frame we're interested in. So while the sentiment was derived from running these articles through Microsoft Cognitive Services, I also mentioned that we ran them through a natural language processing software called NetOwl, and that is used to determine these different relationships and events. So using NetOwl, we can scroll through here and determine some of the linkages that the natural language processing software was able to pull and then store. So here we can see that Vladimir Putin was pulled as a person, and he was linked to his title, which is president. So we can see a couple different examples here, different prime ministers. Putin again here was pulled, as well as the United Arab Emirates recognizing Abu Dhabi. We can do the same as well for different events. So we can see what's happening now in Moscow, how we can relate that. We can see this entity of 370 people who have died and tied to a spatial location of Japan. We can also understand what's going on in the different prefectures in Japan and what hospitals they will need to open, probably as a response to the people that we saw were dying in this other event. So using ArcGIS environment and these different natural language processes, we can really see way more combining them than we could in either of them alone. So we can see not only the sentiment of the articles and their relationships, but also how they relate spatially and because where news is happening is almost as important as what's going on. So with that, I will finish up and open the floor up for any questions on natural language processing, or if we have any more on LocateXT.
Great. I think we'll start with the LocateXT questions first.
Okay.
We had some questions about being able to point LocateXT to a server. And then if you could also explain a little bit more about the LocateXT server component, I think that would be good.
So so when you use LocateXT, you're able to publish that information to a server. You can also create a geoprocessing tool, which can then be pushed to the server as well using those different ArcPy functions. So not sure if that's 100% answers the question, but yeah, it is integrated pretty seamlessly in a server environment and can be used then as a geoprocessing tool in the web if you utilize it that way. And if that doesn't fully answer your question, you can feel free to email me and we can go into it a little bit deeper.
Great. Does LocateXT incorporate optical character recognition to extract locations or coordinates, as in if pages of a PDF or PowerPoint were scanned as image files?
So as of right now, I do not believe that it does that, but it is a question that has come up a decent amount, so I think it is being worked on.
Great. So the next question has to do with some of the language translations,
Okay.
whether that be through NPL or how LocateXT deals with those special foreign characters.
Okay, yeah, I can show you an example of that. With natural language processing or LocateXT, essentially the basis behind what you're working with when you're capturing place names. Sorry, let me just find this file here. So essentially the basis between these places is going to be what's called a custom location list or a gazetteer. So this is going to be an example of actually Ukrainian cities. So this has been customized and created to capture Ukrainian city names and then their corresponding coordinates. So this is going to be kind of the backing of both LocateXT and natural language processing. So if you're working with a different language, then it's just important to know that you are using a different custom location file so that it knows essentially what to collect. Because above all, LocateXT is just going to be scraping your data, be that for a coordinate or for one of these location names that you've defined. So if you're using another language, really it's just important to create your custom location file within that different language so that it knows exactly what to look for.
Great. And then the next question, and the rest of these questions are more focused on the NPL,
Okay.
NLP, sorry. Can the NLP integrate geotagged photos, but then also extract the words in the photo?
I believe it would be able to probably extract the location that's embedded within that file, but I don't believe it would be able to extract locations from that picture. I believe that would be like the scanned document question. But there may be some natural language processing softwares out there that are able to do that. I'm not really sure, but I don't believe so.
Great. In this particular example, can you explain more about the negative versus positive sentiment and how that was determined?
Sure. So, that's kind of based on, as I mentioned, it's run through what's called Microsoft Cognitive Services. So if you really wanted to drill down into that algorithm, I would recommend that you do some research on Microsoft Cognitive Services. But essentially what it does is it's going to run through the article and use machine learning and artificial intelligence, as well as whatever algorithm it's been programmed with, to run through the words in that document and begin to understand based on the language. It is processing the language and determining what that final score is going to be. So I am not an expert on what their algorithm would be, but I would assume that you could look up some information about that. But yeah, essentially each natural language processing software is going to be a little bit different, have a little bit different of an algorithm. So if you were to run it through multiple different softwares, you might get a little bit different results based on the algorithm that each of those softwares is using.
Great. Next question. Can you give us an idea or sense of time or resources it takes to process the news articles?
So these news articles, we go back here and look, since we have been collecting, take a little while to load. I can try and refresh. But since we started collecting in, I believe, October or November, we've been dealing with a lot of articles. This is, over 100,000 here. But when each article is pulled down, it's pretty quick. So this one was pulled at 144, and it's already been analyzed here. So, for each individual article, it's actually pretty quick to run it through. If you were to run all of these articles at once, it would take a pretty long time, but essentially it's pretty quick, and using GeoEvent, we're able to keep it to almost real time for the data showing up on the map. So I would say no more than, a minute max per article. I think it ends up being pretty quick.
Okay, and can you explain more about NLP to extract entities relation?
Yeah, so again, that is going to be kind of based on the algorithm of the different natural language processing softwares that we choose to use. So in this example, we use what's called NetOwl, which is used specifically for this entity extraction and their relationships. And, I'm not 100% sure how their algorithm works, but essentially what it does is, it uses its machine learning and artificial intelligence to try and determine, based on context, what determines if someone's a person. They can probably use, they can determine reading through that article if that's a person, and then, if that person is constantly being discussed in articles with the same thing, So, if Ben Golliver is constantly they're constantly finding his name in articles of the Washington Post or about the Washington Post, and they can start to create that linkage using the algorithm and the machine learning and realize that those two are actually probably linked. And based on this algorithm, it's able to determine, affiliation, titles, that sort of thing. So I do not know enough about the specific algorithm, but that's essentially how it would work. It takes which different things that are, discussed in close proximity or discussed often together in the same article or the same sources, and it uses that to determine those linkages.
And just kind of to wrap up the NLP questions, where and what are some examples of how people would get access to those tools?
Yeah, so a lot of them I believe do require subscriptions. With NetOwl, I think you do need a subscription. Microsoft Cognitive Services, I believe you would need a subscription for that. So I do not know personally of any free ones, but I'm sure there are ones that you could utilize. But most of them are softwares like the Esri software that you would need to have a license for to begin to use. But there may be ones out there that do not require a license and you could, play around with for free.
All right, final question. Are there any notebooks with examples, such as the NLP and density clustering examples that was just presented?
I do not believe so yet, because this is relatively new, the ability to bring natural language processing and ArcGIS together. I know that we are definitely working on easier ways for that integration to be possible, for customers to be able to use that integration a lot easier. So I can do some research and I can definitely give Margie a link if I'm able to find anything to send out. But I would definitely keep your eyes open, because I know that we are working pretty hard to be able to have natural language processing integration available within our newest releases of Pro and ArcGIS Pro for Intelligence as well.
Great, that's it for the questions.
All right, awesome.
So just to kind of wrap things up here, I will be sending out the slides and the recording once that's available. And there were also a few other more use case based questions that we'll be following up with as well. So if it wasn't specifically addressed either live or through the chat, we'll send up a follow-up email to make sure you get your answer. So thank you so much for taking the time to learn about LocateXT and some of the NLP capabilities, and enjoy your day.